antimatter.
Ooh. Oh, so there really is antimatter.
It is real.
Okay.
It is real.
And what is it against? Why is it against matter so much?
Yeah, antimatter, once we came to understand the behavior of particles, then there are fields in which they operate and they move, there are forces. And if you took a step back and looked at them, there was a prediction that it enabled. It said, this allows there to be a particle, such as the electron, but moving backwards through time. And then you say, well, that's weird.
That is weird.
What does that mean? And so it took some smart heads to come to it and say, well, maybe it's not an ordinary particle moving backwards in time. It is an extraordinary particle moving forwards in time. Thus was born the concept of antimatter. So antimatter would be a particle where the quantum properties are the opposite of what they are for matter.
Okay.
So an antimatter, so what's the charge on an electron?
Negative.
Negative. The charge on the antimatter version would be positive. So rather than calling it an anti-electron, which you can, you're allowed to.
Right.
You're allowed to.
That
We
makes
came up with
sense.
a word for it.
What?
Positron.
A positron.
That's where you get positron.
Keeping it positive.
Keeping it positive. So what we learned is that if you take an antimatter and matter particle and you bring them together, they annihilate.
So,
What?
I'm weirded out by that because isn't there like conservation of energy?
Yes.
Okay.
Well, no. Conservation of mass
energy. Right.
Yeah. Back in the day, conservation of mass, conservation of energy.
Right.
Einstein comes along and said, dude, that's one equation. E equals
MC squared.
You have E on one side, M on the other.
Right.
That's what's conserved. So add up the masses of these two particles. You can look it up. By the way, the masses are identical of a positron and an electron.
Right.
Add them up, write down that number, stick it in E equals MC squared, E comes out the other side. If you convert all of that mass into energy, that's how much energy you're going to have coming out the other side.
That's cool, man.
That's cool.